So lastly, what we have, we will just try to go over it as to what exactly is a Van de Graaff generator. Van de Graaff generator is nothing but a generator which produces charges. It uses the electrostatic potential, repulsion of that potential of charges to, and the repulsion factor to understand what exactly is the amount of charge that can be produced. Here you have a conveyor belt, and the top you have a sphere which is charged. So that's the charges are transferred from using the conveyor belt onto the sphere and vice versa. So that is what is the main concept of Van de Graaff generator. So Van de Graaff generator is nothing but a generator of charges. As the name itself suggests, it generates charges, it produces charges. So that is the reason we call it a Van de Graaff generator. So let's try to understand about a Van de Graaff generator. So in this case, broadly speaking, what we have here, you have a kind of charged shell, which is a metal sphere, which is completely charged. Within it, you have a rubber plate. So this rubber plate keeps on moving. In this, when you keep on moving, so this basically results, it produces large electrostatic potential of the order of 6 million volts. So because of the presence of this large amount of electric potential, this is utilized to produce significant amounts of charges. This is just information for you, and it's not going to be very important. Obviously the construction is important, but we'll not be getting many questions based on this for this day. So hopefully you enjoyed whatever we discussed in this particular module. Hopefully you would have enjoyed listening to whatever we have discussed in the module. Now, if you still feel that there are any particular doubts that you have, so please visit our site www.askIITians.com. In this, go to the discussion board. Here you can find all the topics relevant to your questions. You can post your doubts in these relevant topics. And how exactly you are going to do it? Go to the right hand side corner of your screen. As you can see, you can select the category. The categories are defined here. You can select your category, type down your question. You can use your mathematical symbols as well. Else, if you have the question in the form of an image, you can attach the image, post it. We can assure you that the questions would be moderated and answered between 24 to 48 hours after you post it. So keep posting, and happy posting. Thank you. So finally students, what all did we learn in this whole chapter? We understood about what exactly is the electrostatic potential. I'm stressing on that still as to why exactly is the electrostatic potential. Try figuring it out. So when we talked about the electrostatic potential, we also understood as to how much any amount of energy is required to bring any other charge from infinity to a particular point close to any particular charge. That results into electrostatic potential energy. We try to find out the potential energy of different surfaces using the equipotential concept. So equipotential surface is nothing but a surface on which the potential is completely uniform, and therefore there is no electric field that is present on an equipotential surface. We understood about the concept of dipole and tried to figure out how to find out the electric potential from a dipole at different points. Also, we tried to find out the potential energy due to a dipole at different points. Going further from there, we try to understand about what exactly is the electrostatics of conductors, I mean to say. So that tells us as to how does the charge flows in a conductor and how is it different from that in a non-conductor, that is a dielectric. We further went on and tried to understand about what are the different types of dielectrics. Polar dielectrics are the ones which are of major concern to us. We understood about when you have a dielectric, how the charges are distributed and what is the amount of energy or what is the kind of electric field that is produced in the presence of a charge or in the presence of a dielectric. Going further on that, we used the concept of dielectric in a capacitor. So capacitor is nothing but a set of charges or a set of plates which is used to store charges. When you insert a dielectric in a capacitor, obviously the capacitance increases by the amount of equals to the dielectric constant. So that is what was by finding out what exactly is the capacitance in the presence of a dielectric. We can also combine multiple capacitances either in series or in parallel depending upon what exactly is the combination. And finally, we also understood about what is the potential energy that is there when you have a particular set of charges or a particular charge present in a capacitor. That gave us the amount of potential energy. Finally, we concluded with what to understand about what exactly is a Van de Graaff generator. So hopefully you learned about this and you enjoyed this would have cleared quite a few things. Stay tuned for other lectures in physics, chemistry, maths and biology on askIITians.com.